So yesterday's class we have been discussing about measurement of pressure, right? So in the measurement of pressure, not in the measurement of, we have started with the pressure, and we have been discussing what are the different pressure types of pressure used: absolute, gauge, atmospheric, and vacuum pressure, right? And we have seen the definitions for various pressures also. Like absolute pressure is the pressure which is measured with reference to the absolute vacuum pressure, and similarly gauge pressure is measured with the help of instruments, pressure instruments, and the atmospheric pressure is taken as a datum for a gauge pressure. And vacuum pressure, which is usually the pressure below the atmospheric pressure, is the vacuum pressure. Okay, so these are the various terminologies you have seen, and you have seen absolute pressure is atmospheric pressure plus gauge pressure, and vacuum pressure is atmospheric pressure minus absolute pressure. This is the what you have class while we are finishing. Now today we will start with one problem which is related to your gauge pressure and absolute pressure. So what are the absolute, just note down the problem here. What are the absolute and gauge pressures at a point 3 meter below the free surface of a liquid having a density of this much, 1.53 into 10 raised to 3 kg per meter cube, if atmospheric pressure is 750 mm, and take the specific gravity is 13.6, because this is taken as a mercury, liquid is taken as mercury. And what is the depth of the liquid here? Depth of the liquid is 3 meter. So 3 meter below the free surface, hence depth is taken as 3 meter. Density of the liquid is 1.53 10 raised to 3 kg per meter cube.
Ma'am, yes.
And what is the atmospheric? Is it or audible or not?
Yes, ma'am. Your screen is not visible.
Screen visible.
No, ma'am, it's visible, ma'am.
Just a minute. Is it okay?
Yes, ma'am.
Yeah. So just take this problem. What are the absolute pressure, gauge pressure and absolute pressure at a point 3 meter below the free surface of a liquid having density 1.53 into 10 cube kg per meter cube if the atmospheric pressure is equivalent to 750 mm of mercury. And here the specific gravity is given as 13.6 and density of water is known as usually taken as 1000 kg per meter cube. Now here density of the depth of the liquid is taken as 3 meters, and your density is given as 1.53, and atmospheric pressure is given as, now if it is 750 mm of mercury, then it is, if it is in terms of meter, then it is 0.15 meter of mercury. What is atmospheric pressure? Atmospheric pressure is your atmospheric density of a liquid, rho naught multiplied by your G multiplied by your head, Z naught. So here density of mercury, what is the density of mercury? The specific gravity of mercury multiplied by density of water. So that is 13.6 into 1000. And Z naught is pressure head in terms of mercury, that is also given. Now what is atmospheric pressure? 13.6 into 1000 into 9.81 into 0.75. So if you multiply all the things, you will be getting 1 into 10 raised to 5 Newton per meter square. Now pressure at a point which is at a depth 3 meter below the free surface. So when it is 3 meter below the free surface of a liquid, which means that you have to take here the liquid density is 1.53 into 1000. Why we are doing it is the liquid is different and atmospheric pressure is given us in terms of mercury. So the liquid is having a density of 1.53. So that is different. So you take from the free surface, the liquid has a density of 1.3. So rho P is equal to rho G Z. This is according to hydrostatic law of pressure distribution. Yesterday's class we have seen, right? Now this is P is equal to rho 1 into G into Z1. So rho 1 is density 1.53 into 1000. So G is 9.1 into your 3 is 1000. Here you are multiplying with the, because you need to know what is the density of this particular liquid. And hence you are multiplying with rho1 G into Z1. Then you'll be getting what is the pressure. Now this pressure is nothing but now what is, because this is the pressure which is measured at this point. Now what is absolute pressure? Gauge pressure, atmospheric pressure is nothing but your absolute pressure. So if it is measured above the atmospheric pressure, so there are two things, either it can be measured above the atmospheric pressure or it can be measured below. If it is measured below, it is vacuum pressure. If it is measured above, then it is a gauge pressure. So absolute pressure is equal to gauge pressure plus your atmospheric pressure, then you will be getting the corresponding. Okay. Now we'll pass on to measurement of pressure. How the pressure can be measured? Like gauge pressures, we are talking about pressure measurements. When we are talking about pressure measurements, there are two things. One is manometer, another one is mechanical gauges. So we can use manometers and mechanical gauges for pressure measurements. And if it is manometer or manometers are defined as the devices which are used for measuring the pressure at a point in a fluid by balancing the column of a fluid by same or another column of a fluid. So it is simple glass tube. I can say it is a simple glass tube, or through which you can have a column of a fluid which can be balanced by the same fluid or by some other. So that is the manometer. So simple terminology, you can say if you are inserting a small glass tube at a point where you want to measure the pressure, the column of fluid will obviously flow into the tube wherever you want to measure the pressure. And that is nothing but your manometer. In a simple manner, you can say. And manometers are further classified into, there are two types of manometers, simple and differential manometers. And other than that, you have mechanical gauges. Mechanical gauges are defined as which are used for measuring the pressure by balancing the fluid column by spring or dead weight. So there you are using the liquid or same liquid or different liquid, but in gauges it is measurement is done by fluid column by spring or dead weight. That is the major difference between the manometers and the mechanical gauges. So commonly used gauges are diaphragm pressure gauge, Borden type pressure gauge, and then dead weight pressure gauge and bellows pressure gauge. These are all depending upon only the spring or the dead weight phenomenon. There are four classifications. How the liquid pressure is balanced by means of fluid column by using this concept of either spring or by dead weight. That is the mechanical gauge. Now, if you are taking, we are going to discuss in detail about manometers and gauges. First, we will see about manometers. We are taking simple manometers. A simple manometer consisting of a glass tube having one of its ends connected to the point where the pressure is to be measured, and the other end remains open to the atmosphere. And common types of simple manometers are piezometer, U-tube manometer, and single column manometer. So you can see here, this is a manometer. You can see from the definition, a glass tube having one of its ends connected to the point where the pressure is to be measured, and the other end remains open to the atmosphere. So there are common types of manometers which are piezometer, U-tube manometer, and single column manometer. This is a single manometer in which the pressure is measured by means of inserting a small glass tube here, and you can see this is called a piezometer. First type we are going to discuss the piezometer, the point A where you want to measure the pressure. So this is the pressure measurement you want to make, and here a glass which is bent and it is inserted, and this H is nothing but the column head of the fluid column, and this column is rising because of the pressure at A, and depending upon the value of pressure at A, this H will increase or decrease. So balancing the pressure by means of fluid column is the concept of piezometer. So now you can see the simplest form of manometer is piezometer, which is used for measuring the gauge pressures. So one end of this manometer is connected to the point where the pressure is to be measured, other end is open to the atmosphere. This end is open to the atmosphere. Okay. And the rise of the liquid gives the pressure head at the point. So this rise of the liquid is called this one head, pressure head. And this at a point A, the liquid of say H is the pressure head. Then the pressure at A is nothing but rho GH. Am I right? This is according to your hydrostatic law of pressure distribution. So rho GH is the pressure at A. That is about piezometer. Then if you take about YouTube manometer, in YouTube manometer, you have a same like the point where you want to measure the pressure. Here you will have one U-shaped tube in which one end is connected to the point where the pressure is to be measured, and other end of the U-tube is open to the atmosphere. And the tube contains a mercury or any other liquid whose specific gravity should be greater than the specific gravity of the liquid where you are going to measure your pressure. So here the manometric, this liquid is called manometric liquid in the YouTube manometer, and this liquid has a specific gravity higher than that of the liquid, which is for which we are going to measure the pressure. Now you can see the YouTube manometer in which the point B where you want to measure the pressure, and this is the tube, and here you can see the manometric liquid is the mercury, and there are two columns now, H1 and H2. Here that there are two cases. This is for a gauge pressure in which the pressure is above the atmospheric pressure. So you can see the pressure is above the atmospheric pressure in which the H1 is H2 is greater than, but in case of vacuum pressure which is measured below the atmospheric pressure, this line is much below the level. So H1 and H2 which falls below the center line of the pressure measurements which you make. So here with reference to the center line of the measurements or the datum line, H2 falls above, but here H1 and H2, the depth, the rise of liquid falls below the datum line of the measurement where you are going to make. That is the basic difference you can observe, because vacuum pressure is measured below the atmospheric pressure, gauge pressure is usually above the atmospheric pressure. Okay, so in case of vacuum gauge pressure, how we are going to take is that B is the point at which you are going to measure the pressure, and you are taking this value small p, and usually we draw a datum line AA at this point, and let H1 is the height of the liquid above the datum line. So this is the datum line you can have here. So usually we mark a datum line like this. Okay, and the reference to datum line, here you have, and H1 is the height of the liquid above the, H1 is the height of the liquid above the datum line, and H2 is the, this is, here datum is taken as a day. This is the point, B is the point where you are going to measure the pressure, and you are considering the datum line is AA. Why? Because, here is marked. I'm sorry. Okay, and they have given H1 is the head of the liquid above datum line. The this line gauge pressure measurement itself given that H1 is the head above the datum line and H2 is the height of the liquid above the datum line, and S1 is the specific gravity of the lighter liquid. Lighter liquid is the liquid for which you are going to measure the pressure. S2 is the liquid for heavier liquid, which is the manometric liquid. And rho 1 is 1000 into S1, obviously 1000 is the density of water, and rho 2 is 1000 into S2. As the pressure is same for the horizontal surface. What do you mean by that? Datum line, the pressure remains same, or you can say the pressure on the left limb and the pressure on the right limb on the datum line. So here the pressure remains same on the datum line. So which means that the that pressure above the horizontal datum line in the left column and in the right column should be same. Hence, pressure above AA in the left column should be, what are the pressure in the left column? So here is the pressure at B. It is taken as small p. And if you go downward, you are having, how about what are the pressures you have? Here you have rho 1 G into H1. Rho 1 G into H1. So rho 1 is the density of the liquid on the left column. H1 is the density of the liquid in the left column. And rho, and one more correction here in this figure, there is a mistake actually. Please note down, this is not a manometric liquid actually. This is a lighter liquid. This H1 comprises only lighter liquid. There is a mistake in this. And you please note down, this portion is not a manometric liquid portion. This portion is a lighter liquid. Okay. So this should be rho 1 is the density of this lighter liquid. Above datum line, you have only lighter liquid. There is a correction in this figure. And rho 1 is the density of this lighter liquid into G into H1 is the head of this lighter liquid. So with the reference to datum, this is the datum, this should be lighter liquid. You please make a correction. And hence the pressure in the above the AA in the left column is P plus rho 1 G into H1. And similarly, pressure above AA in the right column is rho 2 G into, because you have only atmospheric pressure on the other side and you are measuring only the above the atmospheric pressure here. So here what you have is rho 2 into G into H2. This is the pressure above the AA on the right column. Now pressure above AA, above datum line AA in the left column should be equivalent to pressure above datum line AA in the right column. So in that case, you will be having P plus rho 1 GH1 is equal to rho 2 GH2. Now what is small p? Small p is equal to rho 2 GH2 minus rho 1 GH1. This is going to be the actual pressure. So if you know H1, H2, you will be able to find out what is the pressure at point B. Okay. So that is for the gauge pressure. Please make a change. This is fully lighter liquid. This is not a manometric liquid. You please make a change. Then vacuum pressure. For vacuum pressure, the level of the heavier liquid in the manometer. So how the pressure above AA in the left column? So you can, because all are falling below the datum line. So if you are taking this, all these things is falling below the datum line. Now what happens is you have P is the pressure which is measured at B plus rho 1 GH1 plus rho 2 GH2. Because when you are talking about these pressures, if you are going, the sign convention is usually taken as we are going down. If you are going up while writing the pressure, especially manometric equation, this equation is called manometric equation. When you are writing manometric equation, top to down, take positive, from bottom to up. If you are going negative sign, you have to consider. So sign convention normally we consider. So here the level of the heavier liquid is the reference to the datum, you can say P plus rho 1 GH1 plus rho 2 G, and the pressure on the right column above AA is 0 because it is the atmospheric pressure. Now what happens is, if you are equating both the sides, then P is equal to minus rho 2 GH2 plus rho 1 GH1. This is since this vacuum pressure is below the atmospheric pressure, and hence you are getting a negative pressure. Always a negative pressure. Now we'll see one problem here. First one, it is a problem related to gauge pressure. So the right limb of a this is called a simple U-tube manometer. One end is fixed point connected to the point where you want to measure the pressure. Other end is open to the atmosphere. Now you can see the right limb of the U-tube manometer is open to the atmosphere, while the left limb is connected to the pipe where you are having the fluid of the cigarette. The center of the pipe is, this is the center of the pipe. The center of the pipe is 12 centimeter below the level of mercury in the right limb. So what is given as the level of the mercury level is 12 centimeter below. So here this is centimeter, and find the pressure of the liquid in the pipe means this point. If the difference in the mercury level is 20 centimeters. So difference in the mercury level, this is the left limb, this is the right limb. So left and right limb, the difference in the mercury level is 20 centimeters. So the simple UT manometer is, and this is the datum line. This is usually the datum line where you are having the interface between your manometric liquid and the liquid for which you want to measure the pressure. Now the pressure of the lighter liquid is having 0.9 specific gravity, and density also you are calculating. And specific gravity of manometric liquid is mercury. Mercury is 13.6 and density you are calculating. And the difference in the mercury level is 20 centimeter. Now write the manometric equation with reference to datum. What are the pressures above this? The pressure above this datum minus rho 1 GH1. Rho 1 is 900 because the lighter liquid into 9.81 into, what is this actually? This is 20 minus 8 centimeter. So this is going to be 8 centimeter. So it is 0.08 meter is equal to other side. So this is pressure above AA on the left limb. Similarly, pressure above AA on the right limb is, you have only 20 centimeter here. So 13.6 into 1000 is the density of mercury multiplied by 9.81 G into 0.2 meter. So you are getting, now you are equating these two, only unknown is, and find out what is your small p. Bring this to the right hand side, you will be getting what is your pressure at the point, this point. Okay. And similarly, another problem for gauge, this is for gauge pressure, and this, yeah, tell me.
Ma'am, can we draw the datum line like in the other liquid also, ma'am? Like we are drawing at the exactly at the interface or like only inside the mercury. Can we also take the datum line to the other liquid also, ma'am? Like
other liquid means where the.
Ma'am, what I mean to ask is, can the datum line pass through two different liquids?
Yeah, that is also possible. That also I will take, because when you are talking about differential manometers, there are three liquids you will have. One is liquid at A, other is liquid at B. You have the connection. This U2 will be connected to another liquid. So you will have liquid A, liquid B, and manometric liquid. Okay. In that case, we'll draw separately. That I will teach you. Okay.
Okay.
So that will be different. That is for the differential manometer. Now we are talking about only simple manometer. Okay. So here this is for gauge pressure and this is for vacuum pressure. So vacuum pressure is obviously below the atmospheric pressure. So the simple U-tube manometer containing mercury is connected to a pipe where you want to measure the fluid of specific gravity 0.8, and it is having a vacuum pressure is flowing. It is given, it is vacuum pressure. The other end of the manometer is open to the atmosphere. This end is open to the atmosphere. Find the vacuum pressure in the pipe if the difference in the mercury level in the two limbs is 40 centimeter. What do you mean by that? This is this difference. Liquid level on the right limb, because as they have given it is vacuum pressure, you are bringing below the center line of the pipe. Okay. If it is not given, then you have to consider like, so now if you go to the previous problem, here the difference in the mercury level you are drawing like this, right? 20 centimeter is the difference in the mercury level, and you are taken above, because this is taken as they have given it is open to the atmosphere, and they have not mentioned it is a vacuum pressure, but here they have mentioned it is a vacuum pressure, and hence obviously you are bringing down the limb below the pressure measurement, actual pressure where you are going to measure, and hence you are having, this is a datum line, and the difference between the left limb and the right limb is 40 centimeter, and the height of the fluid in the left from the center of the pipe is 15 centimeters. This is given as 15 centimeters. Now the specific gravity of fluid is this fluid is 0.8 and this is 13.6, and hence rho 1, rho 2 you can find. And what are the pressures on the left hand side? So obviously, you know, P is the point where you want to measure the pressure. P plus rho, this is taken as rho 1 GH1 plus rho 2 GH2, and this is equivalent to 0. Why? Because 0, because the other side is open to the atmosphere. Here you have only atmospheric pressure, right limb, and hence it is equal to 0 for vacuum pressure. And hence calculate and find out what is pressure value here. Substitute and find out what is the pressure here. Okay. So this is a typical problem for the simple tube manometer, and for vacuum pressure and gauge pressure. Okay. Now we'll pass on to single column manometer. For single column manometer, so usually single column manometer is a modified form of your U-tube manometer. Say it is a modified form of U-tube manometer, in which you will be having a small reservoir having a large cross-sectional area. This is the point you want to measure the pressure, and there is a small reservoir where you are have a storage of the liquid which moves from the point where you are going to measure the pressure, and here the other end is like a U-tube manometer. And you can say here the reservoir normally has 100 times as compared to the area of the tube. The cross-sectional area of this manometer is cross-sectional area of the is 100 times as compared to the area of the tube, which is connected to one of the limbs, say left limb. And due to the cross, suppose the why we are having this reservoir is any variation in the pressure in the change in the liquid level in the reservoir will be very small, and hence why we are going for this is like if you want to go for very minute pressure variation even, and that variation can be notified by means of vertical single column manometers. So where you are having sophisticated pressure measurements or minor measurements, that also can be done by using single column manometer. And there are two types. One is vertical single column, another one is inclined single column. And so here delta H is you can see this is A and this reservoir, and here this is your level of liquid is H2 is the level of the liquid here, and H1 is the height of the center of the pipe above datum. Here datum is taken as X is the datum. Now pressure at A is the pressure what you are going to measure, and A is the cross-sectional area of the reservoir. Small a is the cross-sectional area of the right limb. S1 is the specific gravity of the liquid in the pipe, and this is the manometric liquid. So ρ1 is the density of this liquid, ρ2 is the density of the other liquid. Now what is the fall of a heavy liquid? So what happens when there is a fall of this heavy liquid, which will cause a rise of heavy liquid in the other lamp. So what happens is this area of cross-sectional area of the reservoir multiplied by this delta H is the fall of this liquid in the reservoir. So A into delta H is equal to what happens? This small area of cross-section multiplied by H2. H2 is the rise of the liquid on the right limb. So your delta H is equal to A into H2 divided by A. Now consider the datum YY in the below the XX when there is a fall of delta H, then the pressure on the right limb will be equivalent to this ρ2 into G into delta H plus H2. We are taking the datum as YY when there is a fall. Okay. Then the pressure in the left limb above YY will be equal to ρ1 G delta H plus H1 plus pressure at A. Now we equate these two pressures. So P ρ2 G delta H plus H2 is equal to ρ1 G delta H plus H1 in plus rho pressure at A. Pressure at A is delta H into ρ2 G minus ρ1 G plus H2 ρ2 G minus H1 G. Now substitute this value of delta H here, and what happens is when you are substituting here, considering the ratio of small a by capital A is very small, because cross-sectional area of A is capital A is 100 times than the small a, and hence this variation is values will be very small, and we are neglecting this, and hence the pressure at A will be Rho H2 rho 2 G next 1G. If H1 is known, if you know the and hence by knowing H1 and H2, the rise of the liquid, the pressure at A can be calculated. So if we know the value of this H1 and H2, then you will be able to calculate what is the pressure at. Okay. So this is about single column manometer. Let me give you one problem. You please note down the problem and please try to solve. If I read it, will you be able to take or should I type it? Can you note down the problem? You please solve one problem in the manometers. Then only you will have that habit of doing it. A simple manometer is connected to, is used to measure a simple YouTube. Should I type it or you will be able to take it down now?
Please type.
Yes, to the problem. Okay, a simple YouTube manometer is used to measure the pressure of oil. The oil is having. You can draw the diagram first. Generally, you will know whether it comes under which category? Simple utility manometer, whether it is a gauge pressure or vacuum pressure category, that you have to finalize. It's flowing in the pipeline. Then its right limb is open to the atmosphere and left limb is connected to the pipe. So that is clear. Now the center of the pipe is 10 centimeter below the level of the mercury in the right limb. Okay. And if the difference between the mercury levels in the two limbs is 15 centimeter, then determine the absolute pressure of the oil in the pipe. It is a case of a first problem, am I right? It is the problem which you have done, the first problem in the simple gauge pressure. You please draw, do it, take the problem, do it, and show me the through your video. Just show me your results. Any one of you who have done first, you can show me your results. Nobody is there doing it. I'm not hearing anything. If you take 5 minutes of time and do it, 5 minutes you tell me the answer.
Ma'am, hello. Ma'am, do we have to calculate the absolute pressure or only gauge pressure?
Ma'am,
Okay, not audible, ma'am.
Hello, ma'am.
What happened, sir? Finished, sir?
Someone was asking a doubt, ma'am.
What?
Someone was asking a doubt.
ma'am,
No.
answer is 19227.6.
Tell me. Now only I'm hearing.
Answer is
19.62
19227.6.
kilopascal.
19.62?
Ma'am, 1.962 Newton per
Kilopascal.
centimeter square.
Okay, 9.62.
19.6.
Henry?
1.962.
Yes, ma'am, 19.62
19.62
kilopascal.
kilopascal.
Yes, ma'am.
Okay, fine. Yeah. Okay, pa.
Pascal में बोल.
So I am closing here. Shall I give you an assignment? In properties of fluids and pressure measurements, maybe we need to cover differential manometers, and I will include problems in that also. I will send you an assignment, and please solve the assignment and send. Okay, so that is for your writing practice. If it is a regular class, I will make everyone to do the problems, but since it is online class, I don't know whether people are doing it or not, because it is a problematic subject unless in mind. Okay. Yes, Lokesh, tell me. Lokesh, why you raised your hand? Nothing. Okay. Since it is a problematic subject, you please do the problems, and you can refer the books also, like Bansal and Amritam and Modi and Shet, M-O-D-A-S-E-T-H. That is also one good book for fluid mechanics. So please refer those books for doing problems, and maybe assignments I'll give you and try to complete the assignment for the first unit. Okay.
Ma'am, can you also send today's and yesterday's this Word documents, ma'am?
Okay, I'll send. Yesterday's I don't know whether where I have saved it. Today I will send it now.
Okay,
Yesterday I will.
Ma'am, and please create the new group and upload the assignment in the assignment section, ma'am. Please.
Sure. Today I will do it. Yesterday I was doing.
Because only if you create the group, you will
Today
be
I
able
will do
to
it.
give the assignments for us.
Post that. Yeah, sure.
Yes, ma'am. Thank you.
Yeah. Now I will send this document to you. Anyway, I have ordered for the graphics tablet. I don't find comfortable unless otherwise I am writing it on the board. So if I get the tablet, I will start with the graph. I am feeling difficulty in typing and these things is showing. It's difficult for me.
Okay,
So
ma'am.
yeah, probably by next class, I don't know. Maybe this 1 or 2 days I will get it. then I can write it in the time. You'll also have reading internal. Okay. So then
Okay.
I am closing here. Tilak, you tell me your roll number. I will just 10.
Ma'am, 1031 19117.
Yes, sir. First of all, the absorption, spontaneous emission, and then pumping and population investment are the simulated emission of electromagnetic radiation. Okay.
Okay. I have fine. Okay. Okay, we'll see.
Ma'am, you're sending it
class.
through webmail, ma'am?
Webmail, yes.
Okay, ma'am. Okay.
I have forwarded.